an absolutely horrendous looking integral today. We've got the integral from pi on 2 minus 1 to pi on 2 plus 1 of cos, of arc sine, of arc cos, of sine. So to do this, first thing we'll do is we'll sketch the graphs of cos and sine. So the reason we've done this is to think about the transformation that turns sine into cos. If we have sine of u plus a half of pi, that shifts the sine curve to the left by half a pi, which turns out to be the cos curve. So now then, if we use the substitution where x is equal to u plus half a pi, so we can rearrange for u and get that it's equal to x minus half a pi, and now sort out the limits. The upper limit, b, is going to become just 1, and the lower limit, a, will become minus 1. Nice and simple as well for the differential. Dx is just du. So now we can rewrite our integral. It's going to become the integral from minus 1 to 1 of cos of the inverse of sine, and the inverse of cos of sine of u plus pi on 2 du. But now we know our sine of u plus pi on 2 is just cos of u. So we'll rub that bit out and write in just a cos of u. And now if we look at this again, we have the inverse cos of cos. As long as we stay between pi on 2 and minus pi on 2, everything is good. But we stay between those limits, so that's fine. So we can evaluate this entire thing just to be u. We'll shift everything over here. And get rid of the one extra bracket that we have. Next step then is to use another u sub. But this time we've already used u, so we'll use v. And we'll let v equal to the operand of cos, i.e. arc sine of u. We could rewrite this as sine of v is equal to u. So when we differentiate, we get du is equal to cos of v multiplied by dv. Our limits then, the upper limit b, if we think we want to take now the inverse of sine, that's going to give us pi on 2. And again, for the minus now, it's going to become negative pi on 2. So, rewriting our integral, we're going to have the integral from minus pi on 2 to pi on 2 of cos of v multiplied by cos of v, so that turns that into a square, dv. Now we can rewrite this then as half of cos of 2v plus a half, still with the same limits, pi on 2 and negative pi on 2. Now then we can evaluate this, the half will stay out the front, and what we'll get is sine of 2v plus v, still evaluated, pi on 2 minus pi on 2. So plugging these limits in, half stays out the front, sine of pi and sine of negative pi are both 0, so we're going to have 0 plus pi on 2 minus 0 minus pi on 2. So inside here we've got a pi, we times by the half, so the final answer, just pi on 2.